That's it for this module. We had a look at the different types of errors and how to handle them. You can differentiate between a couple of different errors. There are technical errors where you get this error object and where someplace in your application throws an error with the throw keyword, and you can do that on your own, or some package or Express or Node itself does this. And you can handle these errors with try catch or with then and catch in a promise, for example. And there are expected errors. These are errors which are not technically errors. There is no error being thrown, at least not necessarily. But there you could be dealing with invalid user input, an invalid email, or some file access that should work most of the time but might fail occasionally. Depending on how you treat that, if you throw an error or not, you might still need try catch or then catch here as well. But you could also just use a if check to see, does that email address exist in the database? So a normal if check could do there. And if you want to throw an error, or if you want to forward an error in then or catch, you'll learn that you can use that global Express error handling middleware, of which you can have multiple, which are then executed step by step. You can use that, and Express will automatically call it whenever you next an error or you throw an error in synchronous code. We also had a brief look at status codes, and it is a good practice, or it is definitely something you should consider, that you set the right status codes on your responses so that you don't always return 200 codes, but that you instead let the browser know about certain issues. And that will become more important later in the REST API section of this course, when the browser gains more power, when more UI logic is executed in the browser. And you got different types of status codes. You can have success codes, the 2x codes, redirects, client-side errors, and server-side errors. And you should look at all these codes and see which code is best set for your scenario, your use case. Important, as I mentioned, when you set a status code, this does not mean that the app crashed or that the response is incomplete. It's simply an extra piece of information you pass to the browser. Now that we know how to work with errors, and now that we learned a lot about Node Express in general, let me dive into a little more advanced or specialized topic: file uploads and downloads. Now, it's actually not something that rare. You'll often have a feature like this on your web page, and therefore it is important to understand how you can allow your users to upload files and how you can handle that on your server side, and which different possibilities you have for returning files to your users. So this is essentially what we'll dive into in this module. We'll have a look at how to upload files and, most importantly, how to handle them on the server. And of course, we'll then have a look at the different options you have for returning files. So let's dive in. Now let's start with uploading files. And there we have a really great use case, and that of course is that when we add a new product, we right now always have to enter a URL. That is not a very realistic setup, because in a real-world application, your users who are trying to sell things will probably not have pictures of their products stored somewhere in the web. So we definitely want to give our users the possibility of uploading images. And that is exactly what I'll work on now. Adding file upload means that we have to do two things. The first thing is that we need to adjust our form here to show a file picker to our users. So a tool which they can use to, select a file on their operating system, on their computer. And then the second part is that we need to be able to accept that file in the place where we, handle it, where we handle the incoming request. Now, let's start with the form and let's add a file picker there. So we'll dive into our views, and there it's in the admin section, the edit product EJS file. There we will have our image URL control, this one. And in the end, this image URL should now become a file picker. For that, I'll copy this old block and comment it out so that we still have it around in case we need it later. But this will now become my new image uploader. There I'll just have image as a label. Now that class here, where I try to mark this as invalid, I'll remove that because we'll not have an input where we would add a red border around. The type here will be changed to file. The name, I'll change that to image. And I'll change the ID to image too, also up here, therefore. And now the value with which I'll pre-populate this, I'll remove that. Because even if we're editing this, I will always present an empty file picker, and we'll just have to tweak our backend logic later so that when we're editing this and we're not sending a new file, we simply keep the old one and we overwrite the old one if we do send a new one. But for now, I'll simply set up my file input like this. Now, if I save that and I reload this page, now we have our file picker here, which is a default HTML element. And if we click it, we can select a file, like this boat here. You can pick any file. It should be an image, of course. So now I have chosen that. And now if I would enter the rest and add this product, we would fail. Because right now we got no logic in place to handle an incoming file, to store it, or to do anything with it. And this is the part we'll have to adjust now. So in the next lecture, I want to make sure that we can handle incoming files just as well as incoming text, which we previously always accepted. So now that we added our file picker, let's work on the backend. And for that, I'll go to my admin controller, which is where I do handle the creation of products. Also the editing of products, which we'll work on later, but for now let's focus on adding a product. And here we are extracting data from the incoming request. Now I renamed my file picker here to image. So the input name is now just image. And this means that here, when I try to retrieve it from the body, I should also target the image like this. Or we can keep this name because it will fail anyways. If I now submit this, like that, and click add product, I get invalid value here, and the image URL does fail because I do have in my routes, in the admin routes, I do have some validation in place where I say the image URL should be a URL, and clearly it is not. So let's remove that validator here for the post add product route, and let's try this again. And now we simply get an error, so the error handling is working, and the error we're getting is simply stemming from the fact that we're not able to extract our image correctly. I can show this to you. If I console log image URL here in post add product in this controller action, and I try to submit this, then you don't see anything here. It fails to log anything there, because we failed to extract an image from the request body. And why is that? Because, keep in mind, you learned this a little bit earlier in this course, for extracting the content of our incoming requests, we set up a middleware in app.js. We're using a special middleware, this body parser middleware. And this middleware uses or exposes a couple of different parsers, and we're using the URL encoded parser. Now, URL encoded data is basically text data. So if a form is submitted without a file, so just with text fields, no matter if that text field then stores a number, a URL, or plain text, but it's all encoded in text when it is submitted. This format is then called URL encoded. And actually, we can see that. If we open the developer tools and go to the network tab in there, if I do click submit here, this failing request, this add product request, if we have a look at our request headers, we can see that the content type is application and then XWWW form URL encoded. And this basically means it tries to put all the data as text into its form body. We can see that down there, this form data, title, price, and so on, and just image. This is invalid. This is basically an empty text because it can't extract our file as text, because a file is binary data. Now, because of that failing extraction, we need to work with this differently. We need to parse our data differently. And the body parser we're using here does not give us any parser. It does not include any parser that could handle file data as well. We need a new package for that. So let me quit that server and let's install a new package with npm install -- save. And the name of that package is Malter. Malter is another third-party package that parses incoming requests, but this package parses incoming requests for files, so it is able to handle file requests as well, or requests with mixed data, with text and file data. We'll still keep body parser because we still have, like for example, our sign up form where we only submit URL encoded data, but now we'll have to use a different encoding. And that starts with our form. So back in the view, the added product view, there I'll change my form here a little bit. Besides the class and action, here I'll also add a new field, and that's the enc type field, which I'll set to multi-part form data. Application xwww form URL encoded is the default, but now we'll switch to multi-part form data, which is simply the content type telling the server that this submission, that this request will not contain plain text, but will contain mixed data, text and binary data. And Malter, the package we just installed, will be looking for incoming requests with this type of data and will then be able to parse both the text and our file. So this is what we get there, or what we will need. And now with all that prepared, let's use Malter in the next lecture. So let's use Malter now on our backend. We can restart the server already because we installed that package. And now let's go to our admin controller and let's work on post add product here. We want to use Malter to extract incoming files. Now, Malter is actually not a package which we will use in here. Instead, just like the body parser we use here, Malter is some middleware, which we execute on every incoming request, and it then simply has a look at that request, sees if it's multi-part form data, and tries to extract files if that is the case. So it is some extra middleware we add, and therefore, we can import it here in our app.js file. We can import Malter by requiring it from the package like this, Malter. And thereafter, we can use it. So maybe after the body parser, we can use Malter. Malter has to be executed as a function. And then we have to call another method on that, and that simply defines if you expect to get multiple files or only one file. And we will only expect one file, so we use the single method. And then we define the input name which will hold the file. And in our case, that is image. And this is not a random value. I'm choosing image here because in my view, this input which holds the file, so this file picker here, is named image as well. So with that, we initialize Malter, and let's now see if that works. Now, to see that, we need to know how Malter will actually store the incoming file. And for that, let me go back to post add product, and instead of extracting request body image, let me access request file here. And let's see what this gives us. I will also console log image URL now. Now let's save all that and see what that gives us. If I now try to add a product again, I'll choose that same file from before, enter any values up here, click add product, and I still get an error. Now if we go back, we see something interesting though. Indeed, here, this part is what I log here. So here what we see is that Malter seems to have done something. It seems to have stored something in that file property on our request object, and that is what we print here essentially. And it stored the name of the field where it extracted that. It detected the file name. It detected the MIME type, so which type of file that is, and that buffer here is essentially how Node handles the binary data. You learned about streams and buffers earlier. In the end, this is the result of the streamed data. The file basically was sent to our server as a stream, or was handled as a stream to handle it efficiently if it was bigger. And then this is the collected data in a buffer, which, as you learned, is like a bus stop. It gives you a way of working with the stream data. Here in this case, it's the combined streamed in data. And we could indeed work with that buffer to turn it into a file. Now you can actually configure Malter a bit differently. If we go back to app.js, when we set up Malter, we can pass an object to the Malter function, and there we can set some options. And one option is the dest option. Now here, we could specify /images, or just images like this. What this will do is that when I, again, add a product here, and don't worry that it still fails because we're trying to store the file in the database right now, and we'll do all kind of stuff with it for which our code is not prepared, but the upload works. But with this option set, you also see that the output down there changed a little bit. We don't have the buffer because now Malter is able to do something with the buffer. Instead of just buffering it all in memory, it can then turn that buffer back into binary data, you could say, and it stores it in this path here. So indeed, if you have a look at your folder, you should now have an images folder with some file in there. Now that file has some random hash name, does not have a file extension, and is not recognized as an image. But indeed, if I change that and I add .png at the end, this is the image I uploaded. So this does work. All we now need to do is we need to tweak the way this file is named. And that is something we'll do in the next lecture. We added Malter, and as we can see, Malter is able to accept our incoming data, extract the files, and store them for us, and then store information about the file upload in this request file object here, which we output, which in the end contains this data. Now, all we have to do is we have to ensure that our data gets stored correctly. And for that, we specified the destination folder, but we can do more. We can set the storage key here, which gives us way more configuration options than just the dest option. Now, for that, to configure a storage here, I will actually set up a new configuration object, maybe up there. File storage, the name is up to you. It's a constant, and the value will be something I get from the Malter package. There, it's the disk storage function. Disk storage is in the end a storage engine which you can use with Malter, and there you can pass a JavaScript object to configure that. It takes two keys, it takes the destination, and it takes the file name. These are two functions which Malter will then call for an incoming file, and these functions then control how that file is handled regarding the place where you store it and regarding the naming. So destination, therefore, is a function. We can make it an arrow function, which will be called by Malter, which receives the request object, the file object, and a callback, which you have to call once you're done setting up the destination. So this is all to interact with Malter. So in there, you can, for example, call the callback with null as the first argument. That would be an error message you throw to inform Malter that something is wrong with the incoming file and it should not store it. But if that is null, you tell Malter that it's okay to store it. And then the second argument is the place where you do want to store it, like that images folder. Now, file name also is a function, so it's also an arrow function, where we also receive the request object, some data about the file, and a callback which we have to call to let Malter know how to name it. And there, we can also call this with null to still inform Malter, okay, we're fine, store it please. And then the second argument is the file name which we want to use. And here, we could name it image.png, but of course that would be a bit boring. Instead, we can extract file, and then there is an original name object which holds the original file name. There also is a file name object which holds this random hash. In the end, what we can do here is we can, of course, combine this. We can, for example, say, I want to ensure that if we have two images with the same name, they don't overwrite each other. So I will use that file name, which is auto-generated by Multer, and then I'll concatenate it, maybe with a dash in between, with the original name. With that, I also ensure that I end with that extension. And now I set my own file name here by calling that callback. Now we just need to inform Multer that we want to use this storage engine, and we do this by setting this as a value for the storage key in the Multer options. Now with that, if I go back and I add my product again, so the same input, boat PNG selected, you will see that in this images folder, you now have undefined boat PNG. Now it's simply undefined here instead of that random hash, because since we did set our own file name with this function here, Multer does not auto-generate that hash. But what we can do, for example, is we can use the current date. So new date to isostring gives us a snapshot of the current date, and that should also ensure uniqueness. If you need more, you can use some third-party package that does give you a truly unique hash. But with this, we're now storing files with the right extension and a unique name. And this gives us more power because now we can control the path and the file name. And of course, we can also use it for even more, because maybe we want to validate that we only support certain MIME types, let's say PNGs and JPEGs, but not GIFs or PDFs. Let's do that in the next lecture. Now we added our Multer configuration to rename our file and to control the storage place in detail. Now we can also add a filter to Multer to only allow certain kinds of files. And for that, to the object where we configure Multer, I can add the file filter function here. Now I'll again create this in a separate constant up there to make it easier to read. File filter will simply be a function. I'll use an arrow function here, where I get the request, some file data, and a callback which I have to call. And in there, we should call the callback with null as an error and true if we want to accept that file, so if it should be stored, or false if we don't want to store that file. Now, how can we determine whether we want to store it? Well, we can write any logic we want here. And I will check if the file MIME type is equal to image/PNG, or if the file MIME type is equal to image JPEG, or if the file MIME type is equal to image JPEG with an E. If any of that is true, so if I have a file which is of that type, then I will accept it, so we'll call the callback with true as a second value. Otherwise, I'll call the callback with false as a second value, which means I'll not accept that file. And now we can use that file filter and pass it as a value for file filter in our options here. And with that set up, we got some logic here that should filter out invalid files. So if I go back now and I submit a form here with, let's say, my boat PNG, I succeed here. Well, I get an error here, but I succeed because it stores the file. But if I try to submit a different value, let's say I'll pick a PDF here. You can use any PDF, any non-image file. Then you see I only get undefined here, and that undefined is stemming from my admin controller from this line. So then Multer did not store anything. And this is how we can filter out files. Now I will remove all these files up there, and I'll also clean up my database soon, because right now we're not really storing the data appropriately. And that is the next step we should do, of course. So I'll just quickly clean up all my products here, because they're all stored in an incorrect way due to, well, how I worked with the files in the past. So let me remove all these products. And now let me go back, and here in my application, in post add product, so in my admin controller, there I now want to handle that file correctly. So first of all, image here will be an object of this format with information about the file and where it was stored, so where the physical file can be found. And now I want to save that. First of all, I will check if image is set, because if it's undefined, then that means that Malter declined the incoming file. So if this is not set, if it is undefined, well, then I want to return a response with status 422, because I then have an invalid input. So I want to return that response. Add product, editing false, has error is true, where I pass in my old data, not the file, however, only title, price, and description. And the error message is attached file is not an image, let's say. And validation errors can be an empty array. I won't mark anything as red. With this change in place, we can already validate this. If I now try to upload an image, I succeed, so I don't get my same form again. If I choose a PDF though, then I get attached file is not an image. So this is working, and let's now also work on the case that we do have an image and that we want to store it. Now, the file already gets stored on our file system, and this is how you should store it. You should not store data like this in the database. Files should not be stored in a database. They're too big. It's too inefficient to store them in a database and query them from there. Store files on a file system, as we are doing it here. But of course, you need to store something in a database. You need to store the path to the file, right? And that is something you can construct here with the information given to you in the file object. And you can then simply pass that data to the database. So if we made it after our entire validation here, I know that I have a valid file and valid input data. And then I'll create my image URL again. And in that image URL, I will use my image data, which is that file object we get from Malter, and there we have information like the file path. And it's this path that is interesting to me, of course, because this is the path to the file on my operating system. It is the path I therefore want to use later on when fetching that image. So this path is what I'll store here in the image URL, and therefore I can store image URL in the database again. So if we now save all of that, and I do select a valid image here and I hit add product, this now works again. Displaying it does not work. We'll work on this in a second, but saving does work. If I have a look into my database for the products, you see this is the path that was stored. Now this is looking good, but of course here, if we inspect this, we see the image is not really rendered because it can't find this. It fails to fetch images and then, well, this name. And in the network tab, we indeed find a 404 error when the browser sends the request for this image. So now that we are able to store data, let's also learn how we can serve data. Well, almost. Before we serve it, let's work on editing this, because this is another part which won't work correctly right now. Right now, when we load the edit page, what we do is we load the page and we send back the data we need for displaying it, of course. So that means we render the added product page with product data. And that includes our image URL, which is of course fine. But ultimately, here we don't see the URL and we don't want to change the URL when editing the product. Instead, here we have a new file picker. Now, you can, of course, configure this to work in any way you want. But here I want to have a behavior where if we choose no file here, we simply keep the old one. And we only overwrite it with a new file if I do choose a new one here. So to do that, I'll go to post edit product, which is where we do handle the incoming data. And of course here, we again can retrieve request file and store that in a image constant, just as I'm doing it here when we add the product. There I'm also retrieving this file extracted by Malter. Malter will do the same for post edit product, so I can extract it there too, store it in image. And now this image is the thing I need to check. If it is undefined, then I know no file was saved. And in this case, this means I want to keep the old file. By the way, the same will be true if I upload a PDF. I will simply keep the old image in that case. So we don't need to throw an error or return an error message, though you could of course do that if you want, if you always want to force a new image. But here what I'll do is instead, I'll first of all edit my validation page, which I return, and I'll not return the image URL here. We don't need that, just as in post add product. There, we also don't need to return that, because there is no image URL we render in our edit page anymore. But if we make it past our validation here, when we store the product, or when we update the product, I should say, this image URL does not exist anymore. Instead here, I want to see if I really need to set that. So I'll check if image is there, if it's not undefined, in which case I'll set product image URL to image path. So the same logic as I do have it in post add product, there I also set image URL to image path. But in post added product, I do it conditionally, and if the image is undefined, so if no new image was passed, I simply don't set it on the object, which I then update. And since I update it, and if I don't set this, I will simply, well, not update this field. And I can prove this to you. If I update this product here now, I get an invalid value because I forgot to adjust my validation middleware in the routes folder. For editing the product, I'm still checking for image URL to be a URL, but this field does not exist anymore, so we should remove that from the edit product route validation logic. And now if I submit this again, it just works. If I now choose a different image though, and before I select this, let me quickly show you. If I update my database here, you see that image URL did not change. If I select boat 2 now, which is the same image but a different file name and technically a different file therefore, I update this, and now if we go to the database and we refresh, we see it set boat 2. So now we got that editing option in place too, and now we do handle the file uploads in the way we need to handle them. But of course, handling file uploads is only one thing. We also want to be able to see that image, so to download it, kind of. And that is what I'll focus on in the next lectures. So how can we ensure that all our beautiful images are also served to the client, that they are downloaded? We got multiple options for serving files, and I will walk you through all of them. Now, option number 1, which you would typically use for a scenario like this, where you have files that are publicly available to everyone, like our product images, is that we simply serve our images folder in a static way. What does this mean? This means we go to app.js, and there we already are statically serving a folder. We are serving the public folder with the Express static middleware. Now we can serve more than one folder statically. And remember, statically serving a folder simply means that requests to files in that folder will be handled automatically and the files will be returned. So all the heavy lifting is done behind the scenes by Express then. I can duplicate this middleware and now also serve the images folder, just like this. And with this little change, if I save that and the server therefore restarts, if we reload this page, we still fail. Well, if we inspect that failing request, we see that it tried to get the image from admin/images. The reason for that is that I'm on the admin route here, admin products to be precise. So it's only replacing the last part of my path with that image URL. And the solution for that is pretty straightforward. In our view, products.ejs, where I do show my image, we simply need to add a slash at the beginning, which will turn this into an absolute path, so it will not append it to the current path, but rather create a new path with only our domain, and then the path which gets rendered here. And I do this in products, and of course also on my shop pages, so on index.ejs. So basically everywhere where I do render an image, I add a slash at the beginning. The alternative would be to store that path in a database with a slash at the beginning, of course. Might have been easier, but I want to show you both ways. So here I'll add it in my views. Also here in the product list EJS file, like this, and also in the product detail file, of course. There we also have an image. If we change all of that, and I now reload this page, I still fail. And now the reason for that is something different. The reason for that is that the path now is correct, but my images here in the images folder are served incorrectly. In app.js, where I set up this static middleware, keep in mind what I taught you earlier in this course. We basically point to a folder there, like public and images, and we then tell Express serve the files from inside that folder as if they were on the root folder. So we would see that image if we go there and we see the path under which it tried to find that. If we open that in a new tab, we can't find it, of course, but we will see it if I remove images there. And the reason for that is that Express assumes that the files in the images folder are served as if they were in the root folder, so /nothing. Of course, we want to keep them in the images folder and keep the path like this. And for this, we can simply adjust our middleware here and say if we have a request that goes to /images, that starts with /images, then serve these files statically. And now /images is the folder we assume for this static serving. And now with that, if we save that and we reload, we see our image here. So now we got that working, and now we got a static way of serving our files. And that is a great way of serving them. Now I want to do something different though. I want to add this to the cart, order it, so that I have an order, and I want to download an invoice for that order. And that will now work differently because invoices will not be public files that everyone should be able to access. I want to be able to access my invoice, but no one else should be. So let's focus on this in the next lectures. Now for that, let's start with a dummy invoice, and I'll create a new folder for that. I'll name it invoices. You could, of course, put all images and invoices and so on into a parent folder like data to not have them all as root level folders. That might be something you want to do. I'll move the invoices in there. Images is kind of like a special case, but my private data should be maybe somewhere else. So I'll put it into the data folder, which was redundant until now. Now it's not anymore. And I prepared a simple PDF, which I'll move in there. Now this is a really simple PDF. You can write it on your own. It's just holding some text looking like this. So here is my invoice. That is the PDF file I'm serving now. Later we'll also generate this dynamically. Now we won't. Now I just want to show you how to serve that. Now obviously we could make our invoices folder here statically accessible, but that's not what I want to do. Now first of all, let me work on the orders view to make sure we have a link to get that invoice. So for each order, this list item here which we have, let's maybe add a dash in the list item, and in there let's add an anchor tag which says invoice, and then it should be pointing at the invoice. So now if I reload this page, we have invoice here as a link. Now I want to be able to click this and download the invoice. How can we do that? Well, since I want to handle this privately, I need to set up my own route for working with invoices, because that will then allow me to check for things like, is the user authenticated, and so on. So let me go to the routes folder, and in there under shop, because this is a customer feature, not admin related, under shop here, I'll add a new route, orders, and then maybe invoice ID or order ID maybe, because the invoice, let's say, will have a name of that order ID ultimately. We could name this file differently. We could name it invoice, and then let me quickly look up my order ID to make this all work correctly. Got a bunch of orders in there, but this is my latest order which I just placed. So let's grab that text ID here and add that to the invoice name here. Maybe after a dash, we have the order ID, something like this. So this is my invoice, and I'm getting the order ID in this route. I should be authenticated to see that, so I'll protect this route. And then I'll use my shop controller, and there I get invoice controller action, which I have yet to add. So that's why it crashed here, because I don't have that action yet. In the shop controller, at the bottom maybe, let's export get invoice here. And that will be our default middleware function with request, response, and next. And in here, I now want to return that file. First of all, I need the invoice ID for that. The order ID, excuse me. Order ID will be request, and then it's encoded in the URL, so it's params, and then order ID. That is what I specified here in my routes file. Order ID, that's the name, and therefore I have to retrieve it by that name in my controller. So order ID here. Now I have that order ID. The file name or the invoice name we'll be looking there for will be invoice dash and then my order ID and then .pdf, right? That is the format in which all our invoices are stored, let's say. So now we need to retrieve that file. And we can retrieve files with Node's file system. We used that before in the course already. So let's start using it again. Let's import it. File system by requiring file system. This is a core Node module, if you remember. You don't need to install a package. It's already included in Node. And the file system allows us to do things like read files, which sounds like a thing that makes sense here. So let's use the file system and read a file. We know it will be found in the data folder. Now, the path here should be constructed with the path core module so that it works on all operating systems. So let's also import path by requiring path, another core Node module, the path module. And let's construct that path to the invoice. So here I'll have my invoice path, and I'll create it with path join, and I'll be looking for the data folder, that's the first element, then the invoices folder, and then the invoice name, the file name. So this is the path which I want to read. So I'll pass that invoice path to read file. Read file then gives me a callback, so a function, which it will execute once it's done reading that file. So here, I will either get an error or the data. Now, data will be in the format of a buffer. Now, of course, we should check if we have an error, and if that is the case, well, then we simply next it so that the default error handling function can take over. Otherwise, if we don't have an error, here I'll return, by the way, so that the other code won't execute. So if we don't have an error, then data should be my file, right? So then I can call res send, which is a function provided by the Express middleware, my data. Now, theoretically, that should be the file. Now, let's see if that works. And to make it work, we have to use this route in our anchor tag. So in orders.ejs, in this anchor tag, we'll be looking for /orders/ and now we need to output something dynamic with EJS, and that is the order ID, because that's what we're looking for in the route. So the order ID is simply order_ID, which we use up there already. So let's output that here. Let's save that and reload that page. And now let's click this invoice here. And I do get my download option here. Let me save that and try to open that file. And indeed, it should open as a PDF, or you should be able to open it as a PDF. But of course, it was not the most convenient way of downloading this. We had a strange file name, right? This strange cryptic name. We don't have the PDF extension and all of that. So we can certainly improve that. Let's do that in the next lecture. We have our code for downloading a file, and this file is now only available if we are logged in. Now we can improve the way we return this, however. We can pass some extra information to the browser so that it uses a different file name and also the right extension. For this, we'll set some headers. So we can use setHeader for that. And first of all, we can set the content type to application/PDF, because that is what it is here. Whoops, like this. Let's see what this does. If I save it like that, and I now click this button, now I open it in the browser. So this already changes the behavior. It already gives the browser some information which allows the browser to handle this in a better way. And for PDFs, most browsers simply open them inline, so in the browser. So that's great, but we can pass more information. We can also set another header, and that is the content-disposition. This allows us to define how this content should be served to the client. We can set this to inline to still tell the browser to open it inline, for example. So if I change it like this, nothing changes. But we can also, for example, add a file name here. So we can add semicolon and then file name and set this equal to, in double quotation marks, the file name you want to serve. So in my case, it would be the invoice name, right? So we can also set file name equal to, double quotation marks, plus invoice name, plus closing double quotation mark contained between single quotation marks. If I now save this, and I click this button, now we don't see a difference with the file name when opening it inline, because it's open in the browser anyways. But we can change inline to attachment, for example. Now with that adjusted, if we click on invoice, the download menu opens again. And now here we have the proper file name with the proper extension. And this is how you can control how the browser should handle the incoming data. Should it automatically open it? Should it instead let you download it? So I'll switch this back to inline, but keep the file name here. And now I have a setup where only authenticated users can request this invoice. We can still improve that. Now, how can we improve this serving of the data? Well, first of all, right now, this is only available to authenticated users because on my route here, I have the is-auth middleware, but every user could view that. I don't have to be the user who placed that order. However, for that order, I of course know which user belongs to it. I have the user ID here. So we can add an extra check in our middleware, in our controller action here, to see if for this order, the user is eligible of downloading it. Now, how do we do that? Well, we use the order Mongoose model, find that order by that ID in the database, and then check if the order user ID is equal to the ID of the currently logged in user. So here I can check order and then find by ID, and I pass in my order ID. I have then and catch here. Now, as you know, in here we can simply next an error to use the default error handling function. In here, we'll have our order element, though that could be undefined if no order for this ID is found. So if no order is found, then I will also return next with a new error, maybe no order found. Whatever you want, you can handle this differently. If we do have an order, however, I want to check if the order is from that user who's logged in. So then I can check if order user, and then keep in mind, in the user object, we have the user ID field. So if that user ID to string, if that is equal to request user underscore ID, so of the currently logged in user to string. If that is equal, I am allowed to access this. If it's not, so if I'm checking the opposite, if it's not equal, then I will return a new error unauthorized, something like this. And only if I make it past these two if checks, only in this case, I want to read that file and output it. So if I now save this and I access this, it works. If I change the 3 here to a 2, I get my error because now it's an invalid URL. And if I copy that original URL, which was correct, and I do log out, and I try to access this whilst I'm logged out, I have to log in. And if I log in with a different user, Or let me quickly create that user. And I then log in. And I now try to access this order. I also get an error. I have to be the correct user. Now, of course, you could show a different error message, but that is always something you can tweak. I only want to show you how you can protect this and that you have this option of controlling that access. So here, this all works just fine. So we added authorization to our download option here. Now that's not all we can improve. We can also improve the way we are serving that file. Because right now, I'm simply reading that file, and once I read it, I return it. Now for small files, this is probably fine, but you should be aware of one important fact. If you read a file like this, Node will first of all access the file, read the entire content into memory, and then return it with the response. This means that for bigger files, this will take very long before a response is sent, and your memory on the server might actually overflow at some point for many incoming requests because it has to read all the data into memory, which of course is limited. So reading file data into memory to serve it as a response is not really a good practice. For tiny files, it might be okay, but for bigger files, it certainly is not. Instead, you should be streaming your response data. And that is what I will do now. So I'll comment out this code where I read my file, and instead here, I will now start streaming it. For that, I'll create a new constant. I'll name it file. And I will use the file system and create a read stream because I want to read some data in. Now, I want to read in data at a specific path, and the path hasn't changed. It's the invoice path. So now I have that read stream, and Node will be able to use that to read in the file step by step in different chunks. I will then take my response code here where I set the headers. I still do that on the response object. And then here, I will use that file read stream and call the pipe method to forward the data that is read in with that stream to my response, because the response object is a writable stream actually. And you can use readable streams to pipe their output into a writable stream. Not every object is a writable stream, but the response happens to be one. So we can pipe our readable stream, the file stream, into the response. And that means that the response will be streamed to the browser and will contain the data, and the data will basically be downloaded by the browser step by step. And for large files, this is a huge advantage because Node never has to preload all the data into memory, but just streams it to the client on the fly. And the most it has to store is one chunk of data. Again, we're back to the streams and the buffers. The chunks are what we work with. The buffers basically gives us access to these chunks. And here we don't wait for all the chunks to come together and concatenate them into one object. Instead, we forward them to the browser, which then is also able to concatenate the incoming data pieces into the final file. So with this setup here, let's try this again. Click on orders, click on invoice. And again, we see the invoice as before, but now this is actually streamed data created with that create read stream thing, which is the recommended way of getting your file data, especially for bigger files. Now that we learned how to save files and how to return them in different ways, statically, as one big file, or as a streamed response, let me show you a little bonus, so to say, where we can create a PDF on the fly on the server. Instead of serving that hard-coded PDF here, let me create it on the fly instead. So I will delete my invoice here, and instead, when we get the invoice for an order, I don't want to serve a file that already exists, but I want to generate that file based on the real order data. For that, I first of all will still check if we have that order and if the user is allowed to access it. But of course, this will now change. Well, actually, the name will be the same and I will store it in the same way, but I now can't read the file. I need to create it. And how can we create a PDF? Well, there are third-party packages which we can use, which make it a lot easier. And PDFKit is a very prominent or popular package for creating PDFs on a Node.js server. I strongly recommend checking out their documentation to learn more about all its many options because it's super powerful. It can do a lot of stuff. So definitely worth having a look at this. And we will use it to create a very simple PDF in this course here. Now, for documentation, it's important to know that this documentation uses CoffeeScript, which is like a superset to JavaScript. It's not supported by Node. It's just a tooling for writing your code. It's compiled back to normal JavaScript. And therefore, this documentation can be a bit hard to read. In the end, you could say something like this, new PDF document. Here we would have curly braces after it. Require would be using curly braces. So some stuff here looks a bit different, but I will show you how to use it in this module, in this lecture actually. Let's start by installing it. So I will simply run npm install --save pdfkit. That's the name of the package. You'll also find these instructions on the official page. Npm install pdfkit. And then we can start using it once it's installed. So let me start that server again. And up there, in my shop.js controller file, I'll import pdfkit by requiring pdfkit. So this package we just installed. Actually, pdfkit exposes a PDF document constructor. So let's maybe name it like this. So PDF document. The name is up to you, but this is closer to what this package really exposes. Now I want to create a new PDF document when we get an invoice at this point here. So let's create a new PDF doc, whatever you want to name it, by calling new PDF document. And that's what I meant. You need to add normal parentheses as we always did for all constructors. So now we have a new PDF document. This actually also turns out to be a readable stream. Therefore, what we can do here is we can use the PDF document and we can do two things. First of all, we pipe this output into a writable file stream. So create write stream as a function we can call on the file system package. And to that, we pass a path where we want to write it to, the invoice path in my case. And this ensures that the PDF we generate here also gets stored on the server and not just served to the client. So we create that. And of course, I also want to return it to the client. So I also pipe the output into my response, just as before. The response is a writable read stream. PDF doc is a readable one, so we can do that. Now we have this set up, and now whatever we add to the document will be forwarded into this file, which gets generated on the fly, and into our response. Now let's start simple, and let's now use PDF doc. And let's call the text method, which exists there. This allows us to add a single line of text into the PDF document. So here, let's add hello world, maybe. And then you have to call PDF doc to tell Node when you're done writing to that stream, because you have to be done at some point, right? So here, you simply call end. And when you call end, these writable streams for creating the file and for sending the response will be closed, so to say, or will know that you're done writing, and therefore the file will be saved and the response will be sent. And now with that saved, just make sure you also change your setup down there at the bottom. I will keep the headers, but I will not pipe any file because we now, pipe the file up there when we create it, and I just need to make sure that I set my response headers accordingly. Now with that, if you save that, and you click on that invoice link, you should get a PDF with Hello World in there, and this PDF also can be found here. Now, it might look a bit strange here, but you can open it with a normal PDF reader and it should look like a PDF. So this is how you can create a PDF on the fly. Now in the next lecture, let's actually populate it with some order data. So let's create a more useful PDF now. Now, you can configure a lot, and the official docs of PDFKit are the place to go to learn more about that. But let me show you how you can generate some nicely looking PDF in little time. For example, let's set a font size here of 26 and then add some text. And this text will now have this font size. And this will have text of invoice. If I now save this and I reload this page, we get invoice written like this. We can also pass an object as a second argument here and configure this. For example, we can set underline to true here on the text. And now if I reload this, we have an underlined text. So of course you can style way more, you can even add images and all that stuff. Now I'm happy with that title. I'll simply add some dashes as the next line here. And then thereafter I want to have my different items. So now I have to loop through all the items that are part of the order. In this order I only have one product, but I might have more products. And actually we can of course do that. If I go to products, I can add this product to the cart twice. And I can quickly create a new product, prod2. And boring as I am, I'll use the same image for 29 bucks. Product 2. Let's quickly create that product. And then after we created it, I can add that to my cart as well. And then I can order this. And now I got a brand new order. Now, by the way, I should place that invoice link next to the order, not next to the product, now that I have a look at it. But doesn't matter, we can change this later. For now, this will always lead to the same invoice, so it does not matter too much. Now I have multiple products in there, and I should loop through them when creating the output. So I can add a for loop, or simply access. Keep in mind, we already have access to the order here, since we fetched it from the database. I can access order products, and products is an array because we store this products array in the database. It will be an array of objects where each object has a quantity and then a product key with more detail information. So I can loop through my products, for example, with the for each method, which is a built-in method provided by JavaScript. I'll then get information about my product, and I can now output some text where I print the product is then the detail object, and in that product we have the title, for example. So I can output the title here. Then let's say we add a blank and a dash and a blank. And then I have prod quantity, right? Because we have the quantity key here directly on the product itself. And then I add, let's say, a times character. And then we want to output the price. So I'll have, let's say, a $sign. And then last but not least, I'll have the product price. So this field here. Now, of course, you could also use the next-gen JavaScript syntax with backticks to make this a bit easier to read. I think it's maybe easier to understand how we are concatenating this from hard-coded values and dynamic values. And now we should be outputting a line of data for each product in that order. Now let's also add a sum at the bottom. And we can calculate that on the fly here. Let total price starts at 0. And if we are looping for all the products anyways, we can use that to also update our total price. Because total price will then be the old total price plus the product quantity times the product price. So basically what we print here as text will then also add it to our total price here. By the way, this can be written in a shortcut with this operator. Now this will always add the result of this calculation to the old total price. And then here, outside of the loop, once we are done calculating the total price, I'll access my PDF doc, output some text here, and that text will be total price, $sign, and then simply total price, like this. With all that, let's save that. And let's click on invoice for this second order. And here, I get my invoice, which looks like this. Now, of course, we can also revert the font size here by setting font size to, let's say, 14, so that we don't use that super big font for all our text. So now by adding this line inside our loop, I ensure that this looks like that. And then maybe just some stylistic thing, though it will not become super pretty, I can add maybe some more dashes here to separate the list from the total price and set the font size of that total price a bit bigger to maybe 20. Save that. Reload. And here it is. Now, obviously, this is not the most beautiful invoice we ever saw, and you can learn way more about how you may style that in the official docs of PDFKit. The important thing is the data in there is correct, so the data does look correct, the total price is correct, and this is how you can generate data on the fly and how you can then return it in a response and also save it in a file, because that is important too. We do both in the same step, and I believe it's very interesting to see which power Node.js has and what you can do with it, especially when also playing around with the features of writable and readable streams, like here, where we are creating a PDF on the fly and we're streaming it both into a file and back to the client. Now, in this module, we covered a lot and we worked with files a lot. Now, one thing you might notice is that whenever we, for example, change an image or when we delete a product, the file belonging to that product, the image belonging to the product, sticks around. Now, obviously, you can't always delete files with the file system package. There, you also got options for deleting files. You could delete files whenever you edit a product, when you overwrite the image. So here, if we are inside that if block and we set a new image URL, then we could also kick off a function that goes ahead and deletes the old image by fetching that from the product first, because we're fetching the product here, so we can get access to the old image path by fetching that path and then using the file system to delete that old image. And we can, of course, also delete the image when we delete the product. So let's add this functionality as a last step now. And for that, I will go to my util folder and add a file, JS file, where I will add some helper functionality. There I'll import the file system. So the file system is imported here. And I'll have a constant which holds a function, which I'll name delete file. This function should accept the file path, and that's it, let's say. In here, I can use the file system package, and there you'll have the unlink method. It deletes the name and the file that is connected to the name. So it deletes a file at this path. So here I pass file path, and then this has the callback we know with an error if it fails. And in here, we can simply check if we got an error. Then I want to throw it again, and then it should bubble up, and our default express error handler should be able to take over. Otherwise, I'll not do anything here. So it's like a method I can always call to pass in a file path and delete that file. And now we can use that in our admin controller. So let me import my file helper here by requiring it from the util folder, and there the file. And now I can use that file helper, for example, in the place where we added a product. If we are in this if block and we know we'll replace the image URL, then before I do so, I will use file helper and call my function there. For that, I need to export it though. So in here, I want to export delete file. This will hold my delete file constant, so this function. And now in the admin.js controller, here I can call file helper delete file, and I pass in product image URL, so that path to that file. And now this should fire. I'm not waiting for this to complete. I continue with my other operations. I'm doing this in a fire and forget manner. So I'm firing this function and I don't care about the result. If I wanted to, I would have to pass my callback here, so a function which then continues with the rest in this function here. But I simply fire it like this. And I will do the same when we delete a product. So in there, when we do delete it, here, I also want to delete the respective image. And for that, I first of all need to fetch my product, of course. So I will have find by ID in here, find it by prod ID, and then here I have then and catch. In catch, I can next any error I get. And in the then block, I will have access to my product. So here I can then execute my file helper. I should, of course, also check if product is not set, in which case I'll also return next with a new error, product not found. And otherwise, I delete that. And I should only trigger delete one here after I found this. Otherwise, we have a race condition where deleting could finish before finding is finished, and that would be bad. So we'll grab that delete one code, move that in here, and return it to return the promise returned by delete one. And then I can actually replace that catch block with my old then and catch block. And this will catch errors in any of the then blocks. And it will also make sure that I first find the product. Once I found it, I delete the image and I simultaneously start deleting the product itself. Let's save all of that and let's see if that works. If I go back to admin products here and I delete product 1, this is cleared. And here I also have one image less. If I delete the second product, it's only 3 images. So this works. The other images are still sticking around because previously when I started deleting products and so on, I did not have that logic in place. But now this works. Fetching my invoice or generating it on the fly works. And thanks to the fact that we store a snapshot of that in the database, it even works after the product was deleted, which is of course the way we want it to work. With that, we have a really nice setup here. Now, one last adjustment I want to make is that I want to go into my views real quick and fix the placement of my invoice link in the orders EJS file. There I have that invoice link next to every product. That is incorrect, of course. It should be next to the order. So next to the order ID, I will have my invoice link so that now if I reload that orders page, I have that link up there, which makes more sense logically. But the behavior, of course, didn't change. That's it for this module. You learned a lot about files. You learned how to add file upload functionality, both in the form and then, most importantly, on the backend by using Multer, this nice middleware, which automatically extracts files from incoming requests and stores them as specified by us, and which also is able to filter out certain file types if we want to. You learned how to store files both for adding and editing items, so how to manage that. And you, of course, also learned how to download files, how to serve them statically with the help of that static middleware Express.js ships with, and how to make sure that this uses the right path. And alternatively, or depending on your requirements, how you can serve files as a response in a route, like with get order here in the shop.js controller, where we saw multiple different options of serving a file that already existed, for example, by loading it into memory and then returning it, or that you could stream such a file instead, or that you can even generate files on the fly if required, depending on what your application requirements are. With that, you learned a lot of things about how to work with files, with streams, with responses, and this hopefully helps you implement file-related features into your next application. I'm really happy with the shape our course application is taking, and we're diving into many exciting features we can build with Node and Express, as you see. Now that we're able to work with files and even generate them on the fly on the server, let's dive back into some work with our database or interactions with our database. There, right now, we always fetch all products when we display the product page. In this module, we'll dive into a technique called pagination, which allows us to split our data across multiple pages, something you typically want to do when you work with a lot of data. So let me show you how this can be implemented with our application in this module. Here's our shop, and I created 3 products behind the scenes. So you can of course create any free products on one or more user accounts, doesn't matter. In the end, you'll have free products. Now obviously we can absolutely display these free products like this, nothing wrong with that. But let's say we have hundreds of products. We would not want to display all these products on one page. Instead, we'd like to split them across multiple pages, and then somewhere on the page, often at the bottom, we'd have some controls to go to page 1, page 2, the next, or the previous page. And that is exactly what I want to implement here, pagination. Now, you can certainly find some third-party packages that can help you with that, and these would be fine to use, but I will show you how to implement it from scratch on your own, because that is obviously how you learn the most. So back in our project, how can we implement pagination? Well, typically, you handle this, as I said, by adding some controls, which always lead to the same path, so always /products or /nothing. But then you add a query parameter. Remember, query parameters are these parameters you add after a question mark, which allow you to specify optional data. And there you could specify something like page equals 1 to load the first page, or page equals 2 to load the second page. And you would change these query parameters with these controls you add. Let me show you what I mean. I will go into my views folder, and let's work on that /, so on that root route, so that index.ejs file here. And there at the bottom, beneath my products, but inside of that first if block, so where I know that I have some products, in there I'll add a new section. I'll give it a class of pagination, because this will be the section where I manage pagination. And my idea is to have a link here, which says 1 for page 1 and 2 for page 2. And here I would go to / and have page equal to 1, let's say, and here page equal to 2. So here I would set a query parameter to value 1 or respectively to value 2. If I save this and reload, we can see that on the left here. Now let's change the styling real quick. So for that, I'll go into my public folder, CSS, and there the main CSS file. And I'll scroll all the way to the bottom right before that media query. I'll add pagination, so that class I added to the section, and I'll set text align to center, and I'll also style my links. This of course is totally optional, but I will style my anchor tags in there to have no text decoration, so to not be underlined. I'll give them a color of, let's say, my green, which I'm using in this project. I will also add some padding of, let's say, 0.5 rem, and give them a border of 1 pixel solid and that same green color. And also some margin of 1 rem left and right. Something like this. If I now save that, I have these buttons here. Now, one more thing. On the whole pagination section, I'll add a margin top of 2 rem. And I also want to make sure my buttons have some hover style. So pagination A hover and pagination A active sets the styles when I hover over them or when I click on them. And there I will set a background of this green color and change the text color to white. Now this is all optional. I just want to have some stylings here for my buttons. So now we have these buttons, and if I click one of them, you can see the URL changes. It's the same path, just /nothing, but I have an optional parameter in there. Now, with that set up here, let's now see how we can work with that parameter on the backend to control the data we are fetching. I'm setting these query parameters, and I can use that data on the backend to control which data I want to fetch. Obviously, I do that in my controllers, and they're in the shop controller. Here, we're working on the index page, so I'm looking for the getIndex controller action. In here, I need to retrieve the information on which page we are, so which data for which page needs to be displayed. So I'll store this information in a new constant named page. And in that constant, well, I will store a request, and then we can get query parameters on the query object provided by Express.js, and there I can access page. Page, because I named that query parameter page here. So now with that, I'm getting that page number, and I'll store it in this constant. Now with that, we just need to define how many items should be displayed per page. And that is something I will store as a global constant in this file. I could also store it in a different file, export it there, and import it here. But I will name this items per page. And this will be, let's say, 2. It should be some number lower than the number of items you have here so that you can see a difference. So I have 2 items per page here. And with that, in getIndex, I know that if I'm on page 1, want to fetch the first 2 items. If I'm on page 2, I want to fetch items 3 and 4. On page 3, I would fetch 4 and 5, and so on. Therefore, we now need to control the amount of data we're retrieving from the database. Find right now gives us all the items, but we can actually control this. In MongoDB, and therefore also on Mongoose, there is a skip function. We can add this on a cursor, and find does return a cursor, to skip the first X amount of results. And here, that would be page minus 1, so the previous page number, in brackets, times items per page. So if I am on page 2, I would skip the first page minus 1, so the first 1 times items per page, items. So on page 2, if I have 2 items per page, I would skip the first 1 times 2, the first 2 items. I don't just want to skip some items, I also want to limit the amount of items I retrieve though, so that I don't just skip the items of previous pages, but for the current page, I also only fetch as many items as I want to display there. And this can be done with the limit method. The limit method, as the name suggests, limits the amount of data we fetch to the, number we specify here. And here, I can pass items per page, because that is my item limit per page. With that, if we save this code, we can reload this first page with the query parameter set to page 1, and we only see the first 2 items. If I now click on the 2 down there, I only see the third item. Because I'm on page 2, I skip the first 2 items and I fetch the next 2 items. And I only happen to have 1 other item. On page 3, if I would enter this, we would not find any products because I have no items for this page. But page 1 and 2 work just fine. So this is the general idea behind pagination. Now, obviously, the idea would be that we update our pagination buttons here based on, the page we are on and the maximum number of pages that are available or something like that. So let's see what we can do there. We are able to skip and limit the amount of items we fetch, and we can control that with query parameters. But my buttons are hard-coded right now, and that is not ideal, of course. Instead, I rather want to maybe highlight the page I'm currently on and then show the next page number or the previous page number. For this, I need to fetch more information. I will find my products and call count here. Then I can also add then and catch. The important thing is, I don't need catch because I'll concatenate my other promise chain later. The important thing here is this will now not retrieve all the products, but simply just a number. So number of products is what I get back in this then block function here. And in that function, I then want to kick off my request where I really do fetch all the data. So we'll return product find in here with skip and limit chained after it. That's important. And then I'll add this then block to continue. So I'll first of all find the count, then I have this number of products here, and then I kick off my normal find method where I then really fetch the items and I skip and limit them. Here I'll add a variable, total items, and I'll set total items equal to num products in here. So now I will have the total number of products stored in that variable here. And when I render the index page, then I want to return that information as well. So not just the products, but also total products. And that will be total items, so that will be a number in the end. And I also want to pass the information whether there is a next page. So maybe has next page, which only will be the case if the total number of items is greater than the page we are on times the items per page. So we have a next page if items per page times page is smaller than total items. Because if we have 10 total items and we are on page 4, then we have 2 times 4, 8 items which we are seeing or which we saw, and we have 10 left, so there will be a next page. Simultaneously, I can add has previous page here, where I can simply return the information whether the current page is greater than 1. If that is true, then there is a previous page because there will be page 1. If that is false because we are on page 1 already, well, then there is no previous page because we can't go lower than 1. I can also return some extra information like the next page, and that will be page plus 1, of course. So if we are on page 1, the next page would be page 2, and previous page would be page minus 1, obviously. We can also add last page to have a way of displaying the highest page number. That is math ceil total items divided by items per page. So if we have, let's say, 11 total items and we have items per page of 2, then the result would be 5.5, and then math ceil would return us 6, which would be the correct value because we would need 6 pages to display all 11 items if we show 2 items per page. So now I'm passing all that information to my products page, to my index page here to be precise, and there I now want to use it. So let's now use all that information we get back from our backend when rendering our index.ejs page. We have all these utility information pieces, these utility variables like total products, has next page, and so on, which hopefully should be helpful. So let's go back to index.ejs, and there, instead of hard coding this, we can now generate this dynamically. Now, I always want to have page 1 here. That is something I absolutely need. Let's say the page next to it should be the current page. So actually, even instead of total products, I should return current page here, which is simply the page number, so that I always know what's the currently active page. So I'm returning current page as well. And here, I can now output equals current page, because I'm now getting that data in my view. And here, I therefore will load the current page number if I should click on that link again. And this current page will receive a CSS class of active, because that will always be the active class. And I'll quickly go to my main CSS file to give that the same style as when I hover over it. So here I'll have my pagination A class with an active class added to it with a single dot. A active will receive the same style as when I hover over it. Now I only want to render this one, by the way, if the current page is not 1, because otherwise I will already render it here. So we can add some EJS logic here to check if current page is equal to 1, or to be precise, if that is not the case. If that is not the case, then I will render this, otherwise I will not render this. So I can now close that, and now this will only get rendered if the current page is not equal to 1, like this. This will always get rendered, the current page, and I also want to render the next page, let's say. So I will repeat this one time here, and this will be the next page. Remember, the next page is some information which I return as well. Next page here. So we'll render the next page, only, however, if there is a next page. And that is another piece of information I do return. Has next page. So let me go back. And here again, if has next page, so if that is true, then I will render this, otherwise I won't. So here I just close that if statement. I also want to render the highest page, so I'll add another anchor tag here, and that will use this last page information. By the way, the active class should of course not be added here, and also not be added here. So here we'll render the last page, and it will lead to last page. Here it will lead to next page, by the way, so we have to adjust this link, obviously. Here it's the last page. And this last page should also not always be rendered. It should only be rendered if last page is not equal to the current page, so if we are not already on the current page, because then this link would already render the link to this last page. And the next page should also not be equal to the last page, because if it is, then this link will already be rendered, and this is then the last and next page simultaneously. But if both is not true, then I will render this. Now let's have a look at this, and let's reload this. And here I got an error, little logical error. Count used to be the function you should use. Now it's count documents. So change count to count documents here. But this error is not coming from that, but in the index.js, here I got a $sign instead of a percentage sign, which I should use. With that fixed, this looks a bit better, but I got 11 here, and then a 2 again, so there seem to be some issues. For one, it's rendering the 1 here, even though the current page is not equal to 1. The problem here is really just the data format. We're comparing strings and numbers here, so I should remove one equal sign. And now this works. And now regarding the 11, next page somehow is calculated to be 11. The reason for that is that page here is a string, not a number, and therefore page plus 1 gets concatenated to 1, 1, so to 11. This can be fixed by adding a plus here in front of request query page. And now this looks better. Now I can switch between these two, and this is looking all right now with that error, this format, this data type error fixed. Now what happens if I load that page without the page query parameter? Then I have this not a number issue here. And to fix this, I can add two pipe symbols here and then 1. And this means if this is undefined, or if this does not hold a true-ish value, then we'll use this value instead. With that, if I save that, and I reload this page, I'll start on page 1, and now I can jump around. Now let's also try this when changing the items per page to 1, so that we should have one extra page. Now, if I reload this with page 1 being loaded, I can go to page 3 and 1, 2, 3. Now, I don't see a 2 when I'm on page 3 because we have no logic for that in our template right now. I could, of course, add that logic to also show the previous page. For that, I can replicate this. And if I have a previous page, then I can show my previous page and link to it here. Now, of course, I want to avoid that I have 2 1s if I'm on page 2, because I would render this link and I would render this link. So I don't want to render this first page if I am on it already, or if it's equal to the previous page. So I only want to render this first page if it's not equal to the current page, and if the previous page is not equal to 1. Now, by the way, since I fixed that data type, we can also work with double equal signs here again. So now if I reload this page, it's in the wrong place. The previous page here should be before this current page. So let's fix that. Reload again. Now it is looking better. Now I can go to page 2, page 1, and that all seems to work. Now let's add another product, product 4, with another deck again, to see how that works with 4 products on the shop page. And now I see the first page, the next page, and the last page. If I go to the last page, I see the previous page and the first page. If I go to 3, well, then I have the previous and the next page, which is the last page and the first page. So now this pagination is working, and you can always, of course, tweak this to your requirements or your different needs. But now this is looking good to me here. Now, with the pagination added to this first page, let's add it to the products page here as well. And to do that, we can of course grab this entire section here from the index.js file, cut it, and create a new include for it, which we can name pagination.ejs. And in there, I'll insert this pagination content. And in index.js, where I had this previously, I can copy that include code from add to cart and add it here, and include, not add to cart, but pagination, of course. And I just need to forward the data into pagination. So current page, previous page, next page, has next page, has previous page. All that data should be forwarded. So I want to forward current page, which value is current page. So the key value pairs here need to be equal. Next page, which is next page. Previous page, which value is, previous page. Last page, where the value is last page. Has next page, where, you guessed it, the value is has next page. And has previous page, where the value is has previous page. Now with that include added, let's quickly test this by going back to the index page. That all seems to work. And now we can grab that include code and add it also on the product list page. There, below this div, I can add my include to add the pagination section there too. So now if we save that, we also need to adjust our controller, because there in getIndex, I have all the logic for paginating. I need that same logic in getProducts. And again, you could refactor this because now we're sharing a lot of code, but I will copy that entire code here, where I get my products, get the count, skip and limit, and so on. So I will copy all of that and replace my logic and getProducts up there with it. Just render something different. The product list view here. Name this products maybe, and the rest should be equal. And now if we save all that, and I go to products, I should update the path here too. to product so that the right item gets marked in the navigation. So now if I reload this page, products is highlighted. And now here, I also have a working pagination in place. Now there is a tiny error I need to fix, because right now if we're on the products page here and we paginate around, I actually load my index page again, because in the pagination EJS file here, I always have this absolute path, / and then the query parameter. Well, I should only have the query parameter so that this gets appended to whatever the current URL and path is. And this will make sure that if I am on /products, I stay there, and if I'm on /nothing, I stay there. So if I reload /nothing, you see the pagination query parameter still gets appended, but if I'm on products, it gets appended there, and I stay on /products, which of course is the behavior I want here. And with that, this is fixed. So now we added pagination to our application. And of course, you can now tweak this, adjust it to your needs, change the items per page you want to display, for example. If you switch that to 2 and you reload, you won't find items on page 4, but you will find items on page 1. And now you got all that logic in place that should allow you to display the data you want to display and to not fetch all the data in one go. And it's important for you to understand that since find uses a cursor, it does only retrieve the items you need. Count documents does not retrieve all, it only counts them, which is faster than retrieving them. And skip and limit also manage or are managed by MongoDB in a way that you only transfer the items over the wire which you really need. So this is not doing some server-side filtering of the data, it really filters it on the database server already. So this is how you can add pagination to your Node Express application. Thus far in this course, we always had a look at a particular kind of request and response. The request was always a request sent from our browser when we submitted a form or entered a URL or clicked a link. And the response always was either a redirect or a new HTML page. Now, that can take you very far, but sometimes you got some work, some requests that will only happen behind the scenes. That means you don't want to get back a new HTML page, you only want to exchange some data with the server, for example. And I will show you what I mean and how this works in this module. So we'll have a look at what asynchronous JavaScript requests are, why we would use them, and how we will use them. So what are asynchronous requests? Well, we have our client and our server, so the browser and our Node application. And that is the setup we had for this entire course. This is the setup you have with any web or even mobile project that you build these days. You have your backend, you have your frontend. Now, typically, you send a request from your client to the server and you get back a response. And as I mentioned, thus far in this course, the response always was a HTML page or a redirect to another route that then returned a HTML page. Now, there's nothing wrong with that, but there are tasks where you don't want to reload the page just to, for example, delete an item. And actually, in modern web applications, the portion that happens behind the scenes grows since we can do a lot with JavaScript in the browser, where we never need to fetch a new HTML page, but where we constantly change the existing page, as this is faster than loading a new one. But that is something I'll cover in the RESTful API modules. Now, the idea behind asynchronous requests is that you do send a request, but that request typically contains just some data in a special format named JSON, and that data is sent to the server to a certain URL or a route accepted by the server, so that logic doesn't change. The server can do whatever he wants to do with that, and then we return a response. And that response is also returned behind the scenes, so it's not a new HTML page that needs to be rendered. It's instead, again, just some data in that JSON format typically. And that is how client and server can communicate through JavaScript, so through client-side JavaScript and the server-side logic, without reloading or rebuilding the page, without exchanging a new HTML page. And that allows you to do some work behind the scenes without interrupting the user flow, without reloading the page. Now let's have a look at how that would work in this module. In our course project, on the admin products page where we can delete products, I want to implement this delete function differently. Right now, when I would click delete, I would simply, delete that, send that request to the server, and get back a new version of that page, essentially, where this product is then missing. And we can see that, of course, on our server side. If we have a look at our admin controller and we have a look at the post delete product action, this action here, then we see that we also extract some incoming data, of course, and then we work with that data to delete the image belonging to that product and then the product itself. And by the end, we redirect back to admin products, which is a route which will return a new HTML page. Now, don't get me wrong. There's nothing wrong with this setup, and you can absolutely use it. But maybe it would be a great user experience if you would never have to leave that page, if you wouldn't reload that page, but if we click delete, we send that information that we want to get rid of that item to the server behind the scenes. The server can then still do its thing, and once we're done, the server will respond just with some JSON data, so some success message or anything like that. And once we get that message in our browser, we can delete this DOM element. So we can delete this article here. We could do all that with client-side JavaScript, so with JavaScript running in the browser, and some help by our server side here. And that is a so-called asynchronous JavaScript request, or this will use so-called asynchronous JavaScript requests. Now, the logic on the server won't change too much, but the way we expose our route changes a little bit, and we'll have to add some logic on our client side. So let's do that now. And for that, I'll first of all go to my public JS folder and I'll create a new file there, the admin.js file. Now you can name it however you want. Important, this is JavaScript code that will now not run on the server, but that will run in the client, so in the browser. I will import this JavaScript file into my products page here. So there, let's say below the bottom here, below our footer, I will import a script with script source, and you have to close the script tag like this. And then I will import JS admin.js. So we'll import that JavaScript file from the JS folder, which is in a public folder, which is served statically. Now this script will execute on this products.js file. And if we load it at the end of this file, we make sure that the entire DOM has been rendered and parsed by the time we execute our JavaScript code. So now we can go back to admin.js and add some logic in there. Now, which logic do I want to add? Well, I want to react to a click on this delete button here. And therefore, first of all, this button should not be of type submit anymore. It should be of type button instead. Actually, I will remove this entire form because this form was required for sending a request through the browser, sending a request with this xwww URL form encoded data. Now, I'll not do it like this anymore. I will get rid of that instead. And instead, I will now gather that data here manually. So I will listen to a click to that button, and then I will gather the product ID and the CSRF token manually through the help of my client-side JavaScript. Now with the form removed, I'll go back to admin.js, and here I now want to get access to all these delete buttons, listen to a click on them, and then do something when they get clicked. Now for that, I'll define a function admin.js, delete product. Here I'm using next-gen code, but this is code that will run in the browser. All modern browsers support this syntax, but of course, if browser-side JavaScript is new for you, you should take a dedicated course on that. This course will not focus on that. But here I'll have a function where for now I'll simply execute clicked. Now this delete product function is a function I can use from inside my EJS and therefore HTML file on that button. I can add on click and simply say delete product. So this function here, delete product like this. Execute that function when we click on that button. If we now save that and we reload this page here, and I open the browser developer tools, if I click on delete, you should see clicked here. Now it's not deleting the product anymore because we deleted that form, right? So now I'm reacting to a click. And now the next thing will be that we have to find out which ID and CSRF token we have. For that, back in the admin.js file, when we click, I want to get access to the field next to the button. I want to get access to the CSRF token and, as I mentioned, to the product ID. Now, how do I get access to the surrounding elements? Well, in products.js, we can pass this to delete product. This is a special keyword, and in the context here, it will refer to the element on which we clicked, so to the button. Now, since I get this, in admin.js, I can access to the button, since I now received this as an argument, and I can prove to you that this is the button by simply logging it. If we reload the page and I click delete, we see the button being logged here. And here it would be that button. So now we have access to the button, and with that we can easily get access to the surrounding inputs. I can simply access the parent node of my button, which will simply be, well, the element around my button. So in this case, this div here. And I can find my inputs in there. The input with the name product ID and the input with the name CSRF, _CSRF. I can do so by using the query selector on the parent node. And here, I'll use the attribute selector to find name equal product ID. Now let me log this to the console to see if it works. If I now reload my page and I go to the console log, now I get that input ID being logged, that hidden input ID. Now, from that input, I can of course also extract the value, which is then just the product ID itself and not the entire DOM element. So with .value added, now I just get the ID. And for the other product, I get, well, the other ID. So now I have a way of getting that. Let's store that prod ID in a constant. And then let me also store the CSRF token. And here I will simply repeat that code, access the element with a name of _CSRF, and extract the value. And now with these two pieces of information, we can now send our asynchronous request to the server. For that, of course, we need a fitting route and so on. So let's work on that next. We have some basic code in place to extract values about the product which we want to delete. Now, to continue, we need a route on the back end to which we can send our JavaScript request. For that, let's go to the routes folder and there to admin.js. Obviously, we already have a delete route here, a delete product route, and we can build up on that route. There's nothing wrong with that. But now, since we'll send the request directly through JavaScript, we can actually use a different HTTP verb. Thus far, we always used get and post because the browser natively supports these for the requests sent by the browser by form submission and by clicking links. It only knows get and post. When we send requests through JavaScript, so through browser-side JavaScript, we have access to other HTTP verbs too, and you'll learn more about the different HTTP verbs in the REST API section. One of them is delete, and this is a HTTP verb, so a HTTP method, which makes a lot of sense for deleting. Now, it's only a semantic thing. We could use post. You can, in general, use any HTTP verb to do anything because you define with your server-side logic what will happen. But it makes sense to try to be clear about your intention. And there is a delete verb. We can now use it, so why wouldn't we use it? So now this is a delete route to delete product. Now I can also change this a bit and maybe name this product dash and then the product ID as a dynamic parameter because delete requests can have dynamic URL parameters. So now we can extract that information from our URL. And I'll leave the controller action as it is, but I will now name it delete product like this because we're not sending a post request anymore, so I guess this name makes more sense. Is_auth is a middleware I will keep in place though. So now with that, let's go to the admin controller, and here I'll rename that function, that handler here, to delete product because I renamed it in the routes file too. And now the product ID, first of all, is not extracted from the request body anymore because delete requests, as it turns out, also are not allowed to have a request body, but instead we now have that URL parameter product ID. So I can extract my ID from there. So I simply change body for params, and that's it. So that gives me my product ID. And then this logic here will still work. I only need to change the response I'll return. I will not redirect anymore because I'll not load a new page. Remember that the request triggering this action will be sent behind the scenes for the existing page. So I want to keep that existing page, and therefore my response will be a response where I send JSON data. JSON data is a special format, and with Express.js, I can use a JSON helper method to conveniently return JSON data. And JSON is simply a data format that looks like a JavaScript object, so with curly braces and then key value pairs. The only important thing about JSON is the keys have to be wrapped between double quotation marks. This is JSON data, and this is what we can return here. And now we can also set a status here of 200 maybe, because for JSON data, this would be the default too, but there, since we don't redirect and so on, where we get a status code set automatically, it would make sense to be very clear about the status code we have. And therefore here, I'll also not use my default error handler where I would load the 500 page. Instead here, I'll also return a response with status 500 now. That is what I mean about setting that status on your own. And there I'll also return some JSON data. The question is, of course, which data? You simply pass a JavaScript object here, which will then be transformed to JSON automatically for you. So here you can pass a normal JavaScript object. You don't need double quotation marks around your keys there. And here we could have a message where I just say success. Of course, not that interesting, but we could do that. And here I could have a message where I say deleting product failed. So now I have that in place, and now we have two important changes. This is how we extract the parents, or the product ID, and now we return JSON responses. Because we don't want to render a new page, we just want to return some data. Obviously, we now have to continue in admin.js and make sure that we send the request and then work with the response data. Whoops, not this file though. I mean the one in the public.js folder here. We worked on the server side and we added a new route, or we changed the route to use the delete HTTP verb and to look like this. And now we need to send a request there from inside our client-side admin.js file, so in the public folder. Here, we can use the fetch method, which is a method supported by the browser for sending HTTP requests. And it's not just for fetching data, as the name might suggest, it's also for sending data. Here, you can pass a URL. So we want to send a request to /product, and then this, of course, needs to be replaced with the product ID. And this will send that to the same server if you don't specify a different host with HTTP and then something. So if you have nothing like that, it will send it to the current host. Here, I will add my prod ID, of course. And then the second argument is an object where you can configure this fetch request. Now here you can set a bunch of things. You could add a request body, but not for a delete request, as I just explained in the last lecture, but for a post request, which you can also send with that, you would set it. And first of all, let's define that this is a delete request. So I'll set method to delete here. Doesn't have to be uppercase, but is a good convention. Now with method set, what else can we set? Well, we can set headers. And in the headers, we could encode our CSRF token because we still need to attach this to our request. And right now we are not doing that. We cannot send it in the request body because delete requests don't have a body. But the good thing is the CSRF package, which we are using on the server, does not just look into request bodies. It also looks into the query parameters, and therefore we could add it there. And it also looks into the headers. So there we can add a CSRF token header. It will look for this key. You find all the keys for which it will look in the official docs. So you can add CSRF token and then CSRF as a value to attach this to your outgoing request as well. Now this will send the request and it will return a promise that allows us to listen to the response. And here I will console log any error I might be getting. And here I'll be console logging any result I might be getting. Let's see what we have there. Now, one important note, by the way, I'm not sending any JSON data with my request here because it is a delete request without a post body. If it were, and that is something we will see in the REST API section, then I would have to parse JSON data in my backend. Because there, right now, and that's just an important note, in app.js, there, right now, we only have two parsers. One for URL encoded data, which we don't have when we send JSON data, and one for multi-part data, which we also don't have there. We would have to add a new body parser that is able to handle JSON data and extract that from incoming requests. I don't add it here because we don't need it here, but we will add it later when we need it. So, with that all in place, with our client-side code adjusted, let's save all of that and let's simply click that delete button after reloading the page and see what we get. Let's click delete. And I first of all get a 404 error that this route is not found, product with some ID. And this makes sense because my route, product ID, is in the admin routes folder. Of course, we only get there if our request path starts with /admin. That is what we configured in the app.js file. So in my client-side admin.js file, in the public folder, I should, of course, point at /admin/product ID. So that's a little mistake on my side. Let's now reload after changing this. And now this is looking good. I get a response with a status code of 200 with request body, which is a readable stream. I'll show you how to get to that request body in a second. And if I reload the page, the product is indeed gone. Now that's a step forward, but of course, I don't just want to reload the page. It should be gone immediately. That would be the main idea of doing this behind the scenes. So how can we make this work? So we get a result, and that's great. Now, first of all, that result had some cryptic body, which was a readable stream. Now, what we can do here in the then block is we can return result JSON, which is a function that will throw a new promise or return a new promise. So I can add another then block. And here I will have the data, so the response body. I don't necessarily need that, but I want to show you how you could get that data that's getting returned by the server. More importantly, I know that either here or here, does not matter. I have a response, so the item was deleted on the server, and now I want to delete it here in the DOM as well. Now, how can we do that? Well, we got access to the button on which we clicked, right? And the button is in the end inside of the whole DOM element we want to delete. So it is this article which I want to delete. So therefore, what I have to do is I have to find this article based on this button. And that's relatively straightforward to do. My product element, and you can name this constant however you want, is basically my button. And then there is a closest method provided by JavaScript. And you pass a selector to closest, which gives you the closest element with that selector, and the closest ancestor element to be precise. And there I will simply use article because I only have one article in my ancestor history here for this button. So if I select my closest article, that should be the element I want to delete. So inside here, let's say, I can call product element remove. That is a function that will not be supported in Internet Explorer. There you would have to access the parent node and then remove a child. And that child would be the product element. So that is a code that works in every browser. Remove would work in all modern browsers. Now with that in place, we can reload this page here. And now if I click on delete, it will eventually be gone. And here we see our success message. And now just to validate that it really only deletes one element and not all elements, let me log in with my other user who also has two products I can delete. These two products. And now let's go to admin product, delete the boat, let's say, and now only the duck is left. So this is great, and indeed, if I go to products, this data really is gone. I can't load it here. So this is how you can use asynchronous requests. Now, of course, there is more you can do on the client side, but this is not a client-side JavaScript course. The important thing here is that you can send data to your backend with the help with these asynchronous requests and how you can include data and how you can handle that on the backend. Before we move on to REST API features, which is a whole new block or a whole new way of interacting with the client, and of which we got a taste with our asynchronous JavaScript. Before we do that, let's finish our online shop by adding some payment functionality, because what would be a shop without being able to pay? Now, for that, in this module, we'll add a simple checkout page. We'll collect some payment data, so credit card data, from our user, and we'll finally do the purchase, charge that credit card, or at least simulate the charge in this module, and, well, of course, then still store the order as we did it before. Now, for that, I'll use a third-party provider, Stripe, which is a great provider for integrating payment into your application, and I will show you how to integrate it step by step. Let's first of all start with the payment process. How does this work? Well, it's a pretty long process. We start by collecting the payment method, so the credit card data typically. We then have to verify that. Is the credit card data correct? Is it expired? Is the number correct? We then have to charge it. And after we charge it, we have to manage payments. So that includes things like fraud protection, also managing disputes, and so on. And last but not least, we of course have to process the order in our app, so in our server-side code, for example, that we stored in a database there. Now, all the payment-related things here are pretty complex tasks, both from a legal and a technical side. And therefore, typically you outsource them. And by the way, even very big companies outsource this. Stripe is a very popular company offering payment services. It offers a great integration, and it's super easy to add to any application, as you will see in this module. How does it work? Well, we have our client and our server, so that is all the code we own and we wrote. And then the client will collect credit card data. We'll do that with the help of Stripe, and we'll send it to the Stripe servers, which are not owned by us, but by that company, to validate that input. Once it is valid, Stripe will return a token to us, which basically encodes or which includes that credit card data and the confirmation that it is correct. We send that token to our server, so to our code, and in our code, we create a charge, or we charge this payment method then with the help of Stripe again. So we create a payment object, a charge object, we send that to Stripe with that token and with our price included, and Stripe will then do the actual charging, do the actual managing, and we will get a response once this is done, and then we can also continue with our code and edit this or store this in a database and so on. So this is generally how that will work. Now let me walk you through that step by step. To add payment to our application, let's work on that checkout EJS file with which we never worked thus far. I want to go there before I actually place an order when I click on Order Now in my cart. So I'll go to this page first. For that, I'll copy the content of cart EJS, add it in checkout EJS to make sure that I have my default head. I'll get rid of that style sheet here though, I don't need it here. I want to include the navigation. The main content will be totally different though. I will keep my body, however. So, or my end here. So with that, I have everything set up to have a basic checkout page. Now let's first of all make sure we reach that before we start adding Stripe. For that, we need a new route, of course, in the shop.js file. Here we have our create order route. And in the end, what I need is a new router, a get route, which we can name checkout. And there, I want to be authenticated because that we can only buy something if we are logged in, let's say. And then I'll use my shop controller and there get checkout, which is an action I still have to create. And in that get checkout page then, we'll have the possibility to create an order and so on. So for now, let's just add this. And let's work on our controller then, on our shop controller. And there I need a get checkout method. So maybe here before post order, because logically it comes prior to that, I'll have get checkout with request, response, and next. And in there, I want to render my checkout page. So we can, of course, grab one of our other render functions here. Render that. Here I will render shop/checkout. The path can be checkout, but doesn't really matter. We don't have a navigation item we want to highlight. Here we can have checkout as a text. And of course, we need some data for the checkout. Now, what do I want to return here? Well, in the end, I will need the same data as I have in my cart. So I need my products here, which I do have in the cart. So I can actually copy that entire code from get cart, I guess, and add this here. And now just make sure we use shop checkout, path checkout, and here checkout. But besides that, I also need to calculate the total, let's say. So total sum, or whatever you want to name it. And that total sum, of course, can be retrieved from our product data. Because in the cart, or in the products here we have in the cart, you have to keep in mind that products is an array of products where we have the quantity and then a product ID field with detailed data about the products, because we populate this product ID field with the detailed product data. So therefore, the total sum can be generated by looping through all products. So here I can do products for each and create a new variable, total, which is 0 initially. And then there, total is equal plus equal, this shortcut to add something to the existing total. So total plus the product, and then there is a quantity field times the product ID, price. And then it's this total which I pass to my view. So that's all the data I should need in my checkout view. So now back in my checkout.ejs file. Now I can indeed grab that unordered list for rendering a list of items. Like this. I'll go through all my products. I'll remove the delete button though. It's too late at this point, let's say. We can, of course, always cancel the checkout process if we want to though. Actually, I'll delete this entire form therefore. This is my unordered list. And below that, we can add a div with a h2 tag of total. And then here I output total sum. Now, let's have a look at that. And to have a look, I need to make sure that on cart.ejs, when we click order now, I don't submit this form here. So we'll actually comment this out. We don't need that anymore. But instead, I want to have a normal anchor tag here where I say order now, where I simply point at /checkout. So this new route we added. And I'll just give this a class of button to look a bit like a button. With all that added, let's go back to our page. Let's go to products here maybe. Add this to the cart. And click order now. And this is now my, the page here. Now it's not looking super beautiful, I'd say. I need to include that cart CSS file again, because since I'm reusing the rest of the code here, and we could create our own style sheet, but I want to keep this relatively short. Since I'm using all that, I of course also want to use the same styles. So now if I reload this checkout page here, this is looking okay. The total could be placed in the middle maybe. We can do that by giving this div a class of centered, which is a utility class I added earlier in the course. And now we have this checkout page. Again, you can always work on the visuals, but it's not so much about the visuals here. So now we have this total, and now I want to add Stripe. And for that, let's first of all set up an account with them. You can simply Google for Stripe and you should find their page. And they have a really great documentation, by the way, in case you want to use it. So definitely dive into developers documentation. But we can simply click create account here and then create an account real quick. Now, once you got your account created, you can already get started. First of all, you need to validate your account. So make sure you click on that verify email link you get in an extra email. And once you did that, you are ready to get started. Now, important, under developers, you'll find a bunch of API keys which you will need to add Stripe. And we are seeing special testing data here, which is fine for our development. If you want to build a real application and you want to push it to production, you would switch to your live data here. For this, you have to activate your account, though. We'll not do that here. We'll work with the test data to get started. And with that, we can go back to home and there click on Grow Your Online Business with Payments and read the docs. Now, this takes us to the Stripe documentation. It turns out that you have various different ways of implementing payments with Stripe. And of course, you can check out their entire documentation to learn all about the different ways of collecting payments. Now here we can go to Web under Build Your Own and click on Integrate Stripe.js. This simply allows us to implement a JavaScript library on the front end, so in our views, to make that whole payment process very, very smooth and straightforward. So what we'll do is we'll pick this script here and go back to our code, and there in the checkout EJS file, let's go to that div where we output our sum, and let's actually add a new div below it, which also has that centered class. And in this new div, we can paste in that script. But not just this script, let's also add a button here with an ID of order-btn and a class of button for the styling, where we can say order, just like this. Now let's add another script tag here, where we now will write some inline script, and that's all front-end JavaScript, so not running with Node.js on our server, but instead executing in the browser of our users. Now here we can, first of all, call Stripe with a capital S, like this, and insert your local testing key. Now you find it here in documentation already pre-filled. This is the key you can also see in the developer part of your home screen. So put in other words, here under developers API keys, this is the key I'm talking about. This is the same key you see here. So you can grab that key and enter this as a string, as an argument here for this Stripe function call. This Stripe function is available because we're running this script here, we're importing this script. And thereafter, let's get access to our order button by using document get element by ID. That's a DOM API, which we can use in JavaScript, which runs in the browser to get access to an element on the page. And here I will get access to that button by its ID by simply passing the ID here. So now we simply have access to the button where I now want to listen for a click. So on the order button, we can add an event listener, a click event listener, and then pass a function which should execute when that button gets clicked. Now here, we'll not send the user to our own backend, to our own routes which we registered. Instead here, we'll let Stripe do some magic. We'll use that Stripe object, which we created up there, and call redirect to checkout, written like this. Now, redirect to checkout takes a JavaScript object where we can configure this. What this will do in the end is it will redirect the user to some of Stripe's pages where the user then enters credit card data and so on. And once all of this is done and the payment is confirmed there, the user is redirected back to us. Now here, we have to provide a session ID. And that's the interesting thing. That should be a string, but at the moment we have no such session ID. So what do we do there? How do we get that session ID? Well, for that, we have to go to the controller where we in the end render checkout EJS. And that, of course, is here in shop.js, the get checkout controller here. Here in get checkout, we now have to adjust our code a little bit. Because besides rendering this checkout page, we have to prepare such a Stripe session in the end. Now, to prepare that, we have to install a new package. So I'll quit my development server and go ahead and install it by running npm install --save Stripe. Stripe is the package name which we need to install. This is now a package which we can use on our server-side code, so in Node.js. So let's wait for this to finish. And I'll then restart my server. And now here at the top, we can import Stripe by requiring Stripe like this. But then this actually gives us a function which we need to execute, to which we now need to pass our private Stripe key. That's the key you have to reveal here. And by the way, of course, I'll change those keys after this recording session, so you can't use mine. Copy that key here and enter this here. Now always keep this key private, so only use it in your Node.js code. Never expose it in one of your views, because there your users could see it, and this is a key you should always keep private. Now with Stripe imported like this, let's go back to get checkout, so to the controller where we prepare the checkout page. And in there, of course, you want to gather all the product's data. That's all fine. However, I will adjust this a bit and create a variable products here right at the beginning of the function, also a total, which is 0 initially, and change this here to not create a new constant or a new variable here, but instead use these variables here, which now simply are available everywhere in this function, in any nested function as well, whereas before this only was available inside of this function, and that will just not be enough once we made the changes we're about to make. Leave that code as it is otherwise, but instead of rendering immediately here, we now need to do something different here. We need to do something else. Here in this promise, in this then block, we should return Stripe checkout dot sessions create. Remember, we needed such a session key in our template. Now here we're going to create such a session, which ultimately gives us such a key. To create, you pass an object where you configure that session. Now, one thing we can already do is we can grab render here, cut that, and add a new then block thereafter, which is why I had to outsource some data into global or into function-wide variables. And in this then block, you'll get the Stripe session eventually. We're not done configuring it, but you will get it there. And in here, you can then render the checkout page and also pass, let's say, a session ID key to the template, which holds session.id. So this session you're getting here, it will have an ID field, which is that Stripe session. Now we'll use that in a view in a second. Before we do so, let's configure that session, because there are some things which we do need to configure. For one, we need to add a payment underscore method underscore types key here. That holds an array, and there we want to add card as a type, which means we accept credit card payments. Next, let's add a line underscore items key, and there we need to specify which items will be checked out. So here I want to use my products, which I basically created here, and map this a little bit because each product needs to look a bit different. So every product will be transformed with help of the built-in map method JavaScript offers on arrays. And there, the new object I returned for every product in the products array, which will therefore be part of the newly returned products array we passed to line items, will have a name, which is p.productid.title, description, which is p.productid.description. In case you're wondering why we can access title and description on product ID, keep in mind that we populated that product ID field. So it's not just the product ID, it's the complete product data, which is why we can access the title and description, for example. The amount is p.productid.price times 100, because we need to specify this in cents. The currency is USD for US dollar, and the quantity is p.quantity. That is data which Stripe needs in the end, and that's the format Stripe needs. It needs an array of objects which have currency, quantity, and amount, and then also here our extra name and description fields. And this needs to be named name, for example. So with this reformatted data, we also give Stripe the data it needs to process the payment, but we're still not done. There is more we need to configure on this session. Specifically, we need to add a success underscore URL and a cancel
underscore URL. These are URLs Stripe will redirect the user to once the transaction was completed or failed. Here, I want to dynamically